Alright, here's the second half of the AP Chapter 5 exam review. Remember, guys, you don't understand a problem unless you can do it by yourself without any help. Now, if you just got stuck on these problems and you needed some help, so that's why you're watching this video, that's awesome. What I suggest to you is that you find another problem like the one you're going to get help on, or you try to attempt these problems 24 hours later. Chances are you might still remember a little bit of what you got helped with, but that's a better measure of if you truly understand the concept. Also, what helps if you want to see if you truly understand the concept is if you can help somebody understand the problem that you now understand or supposedly understand without looking at notes or getting any help. To do this problem, we're going to use a formula. The formula looks like this. Let's see, it says if you have 1 over a squared plus x squared dx, then the antiderivative of this, the integral, would be tangent inverse of x divided by a plus c. When using this formula, you have to be very, very particular because this says that a is squared. So when I identify a, I have to square root that to get a 2. That part's not the hard part. So that's a equals 2. So we know a equals 2. The hard part is this. And sometimes you get confused because there's an x right here, there's an x right here. Like what do you do with that 16? Okay, so instead of looking at this like it's an x, think of it like it's something squared. Okay, we need something squared right here. And this does not say something squared. This says 16 times something squared. So we have to manipulate that a little bit. So let's rewrite the integral that the problem gives us. So I'm going to write the integral of 1 over 4 plus, now I'm going to write 4x squared instead. And I'll put my dx out in front. So now the something squared we know is 4x. So when we do the antiderivative, we're going to get, we have a function inside of the function. So the way I like to look at this is I like to use u-substitution. So I'm going to say u equals 4x and then du equals 4 dx. So now I'm going to take this 4x out so that I have something squared just like we have indicated in our formula. And I'm going to put in a du with the u. So now I have the integral of 1 over 4 plus u squared du. Now this looks exactly like this. Oh, by the way, I can't just plug in du because dx is not equal du. dx equals 1/4 du. I had to get the dx alone so I could sub in the du for it. So 1/4 is going to go out in front. He's our scalar. And now I have this. Oh, perfect. Now that's exactly what I'm given in my formula. So let's just sub some stuff in, or like use our formula. So we have tangent inverse of, it says that x goes up top, so whatever is being squared goes up top, so I'm going to put u up top, divide that by a, and I know my a is 2, and then we say plus c. This 1/4 is going to multiply to our result, so I'm going to multiply the tangent inverse to 1/4. I can multiply the c times 1/4 too, but it doesn't really matter because it just makes a different constant, like a new constant. So our answer is almost done. We just got to sub the u back in, so we get 1/4 tangent inverse, and my u is 4x, so I'm going to put 4x right there, divided by 2. That'll simplify down to 2x. So let's see what we got. Yep, it's right here. Arctan. Arctan is the same as tangent inverse. Don't let that confuse you. D is your answer. My first thought is, oh, is the integral of this inverse trigonometric function? The answer is no, because nothing's being squared down here. And also, if we look at our answers, we see natural logs happening. So let's first rewrite this. Now, I don't know if you see this right away, but I can take a 6 out of the denominator, and that might make things calculate a little nicer. You don't have to do this, but I like to if I can. So I still have a function inside of a function, so I'm going to set that equal to u. Let's see if our u substitution works here. So if I take the derivative of u, we have just 1 dx. Oh, sweet, an easy substitution there. We're going to have 1/6 in front, and I'm going to take that denominator out and put a u, and then we have du. Now, all right, now the antiderivative of 1 over u is natural log of u, so I have a 1/6 multiplying to the natural log of u, and then I got to sub u back in, so I have 1/6 natural log of x plus 2. And actually, yeah, we have to make sure that this is a positive. And so our answer is going to be B. Yeah, don't forget their plus C. Ooh, plus C. All right, let's look at the next problem. Number 13. This problem is interesting. Instead of using U, this problem uses W. So I looked at all my answers here. They all have a DW here. So let's do W substitution. So we're going to say W equals 2x. So I'm going to rewrite this guy with the W. So it's going to say from 0 to 2, f of W dx. Now what we have to remember here whenever we do u substitution is that we also have to take out the dx to make him appropriate for this problem. So we're going to take the derivative of this, so we get dw over dx. On this side we get a 2. We're going to move this dx to the other side, so we have dx, or 2dx equals w, but I only have a dx, I don't have a 2dx, and so I'm going to divide both sides by 2, so I have a 1/2 dw. So if I want to plug in dw for that, I also have to carry along with the dw the 1/2. So since the 1/2 is a scalar, I'm going to put him out in front. We have 0 to 2 fw dw, and our answer is, oh snap, you know, so I didn't change my 0 and 2 to w's. Actually, I shouldn't have written them, so I remembered that they needed to be w's. So now I have to change those numbers, the 0 and 2, into w's. Right now they are x's, and so I take the 2, I plug that into the x, I get 4. So I put 4 right there. I take that 0, I plug it into x, I get 0. So I have 0 to 4, 1/2, 0 to 4, fw dw. That is our answer. Number 14, a population triples every 6 months. So let's see. If we had a starting amount, we're going to call this P naught, and that triples, in populations increase exponentially. What is our growth constant and time? So it gives us time. It says, the problem tells us that in 3 months, so our units are in months, how long does it take for this population to just double? Okay, first we need our growth constant, because we're not going to be able to find out how long it takes for a population to double unless we have the growth constant. Okay, so we need to know this in order to find this, and that's what the question wants. The question wants to know what this t is. Okay, so let's find our growth constant. So we would divide both sides by p naught. There is a formula for this, but I don't like formulas. So now we have 3 equals e to the k times 3. We're going to do the natural log of both sides. So we have natural log of 3, natural log of e, which cancels it out. And so we have natural log of 3 equals 3k. We divide both sides by 3, and we get k equals natural log of 3 divided by 3. Now I always like to check to make sure that this is a growth constant, not a decay constant. It looks like the population is growing, so we're going to call this a growth constant. So we have our k. Let's plug our k in. We have, well, these p naughts are going to cancel out. So we have 2 equals e to the natural log of 3 divided by 3 times t. Now if we're looking for this answer, we're going to do natural log of both sides first to get that t alone, so that cancels out the e. So now I have natural log of 2 equals natural log of 3 divided by 3 times t. Let's get the t alone. So because it's a fraction, I'm going to think of, because you divide it, but that's the same as multiplying by the reciprocal. So let's see, divide by 3, natural log of 3 over 3, that gets rid of that. Now on this side, I'm going to go 3 times 3 over natural log of 3 times natural log of 2. So we have 3 natural log of 2 divided by natural log of 3. Let's see if our answer is there. Well, the answer is not there, but after close examination, it looks like I put a 3 here like a toad, and I was supposed to put a 6. So that changes this 3 to a 6, which changes this 3 to a 6, which would change this 3 to a 6, and this 3 to a 6. So now we have our answer. Our answer is C. What a goober. Alright, number 15. Problem gives us this information. This is what we're looking for. We're looking for g prime of 3. So I'm going to take the derivative of this. And if I take the derivative of that, this is what I get. I take that 2x and I plug that into the t. Remember, when we take the derivative of an integral, the derivative cancels out with the integral. So I better write it out. So if we take the derivative with respect to x of 0 to, is that 2x? 2x f of t dt. This cancels out the integral. The constant doesn't matter. We're going to plug the f or the 2x inside. So we have f of 2x. But then we have to multiply this by the derivative of 2x because 2x is a function. So the derivative of 2x is 2. So we have g prime of x equaling 2 times f of 2x. So for plugging in 3 to this, we would have 2 times f of 2 times 3, which would be 6. So now, let's see if we have f of 6. F is right there, there's 6, so it's 7. So we have 2 times 7. 2 times 7 is 14. And there's our answer. That one's not that bad. Alright, next one. Change our color marker. Oh, hey, this looks like it could be the inverse of sine. See, let's write down our formula. There it is. There's your formula. Memorize it. It makes things much easier. There's other ways to do this problem, like factoring out a 4, a square root of 4, but that does get kind of hairy. Alright, now don't get confused with this x and this x. They're not the same x. But what this is saying, it says that a is something squared. I'm sorry, it whatever isn't in front of the x, the something squared. Hold on, let me gather my words. Okay, I'm just gonna rewrite it. And instead of putting an x right here, I'm gonna put a u. So can we make this into a u squared? Is the question. So it looks like the a in this problem is gonna be 2. But what is the u going to be? What's tricky here is that the squared right now is only attached to the x. We need that squared to be attached to the whole thing because this u does not have a coefficient in front of him. So I'm going to need to do u-substitution to get that, well, I'm sorry, I'm going to use manipulation to make parentheses around that so that the whole thing would be squared. So to do that, I'm going to rewrite it. The 4 stays, but that 9 becomes a 3, and then we square it. Now we have business. Okay, so that's our u. So let's make that into our u. So u equals 3x, and then du would equal 3 dx. Dx would equal 1/3 du. So alright, so I have 1/3 du equaling dx and u equaling 3x. Let's rewrite this thing. We have the integral of 1 over 4, oops, I forgot my square root over that thing, 4 minus u squared. Bam. Wow, it's really sloppy. I'm sorry, guys. Now, this looks exactly like what I need over here. Okay, so we know that a is 2. The u is no problem. Let's rewrite it now. The integral of that is going to be sine, using our formula, inverse sine of u divided by a, and our a is 2. And then we're going to go plus c. Oh, snap. You know what I almost forgot? When I put the du in, I didn't put the scalar in too. So we put 1/3 right here out in front. So I'm going to put 1/3 times the sine. Wow. The classic u-sub mistake there. So to finish off this problem, I need to sub back in what u is, and u is 3x. Okay, so where are we at? 3x divided by 2 is going to be this guy. Arc sine is the same as sine inverse. Alright, let's look at the next problem. Number 17. Alright, midpoint Riemann sum to approximate this using 4 subintervals. So I'm going to draw an x-axis here to kind of help us out visually. From 1 to 9, we need 4 subintervals. So if I divide from 1 to 9 into 4 intervals, see that distance is 8. From 1 to 9 is 8. So I'm going to divide this into 4. Let's see, that would be 2. So we count 2 spaces, 3, 2 spaces, 5, and then 2 spaces, 7. 2 spaces would bring me to 9. So here's my subintervals. I don't need to have exact boxes here. I'm just trying to get an idea of what I'm doing here. Since I'm doing midpoint Riemann sums, I need to know the middle of each of these. A Riemann sum is just finding the areas of every rectangle and adding them together. And depending on the type of Riemann sum, that tells you which x value you're going to use in order to find the height of your function. So, or the height of your rectangle. So this is 2, this is 4, this is 6, and this would be 8. So these are all my midpoints. So what I need to find right now is the points at the top of my rectangles. Because if I find the points, then I know the height. So 2 is the x value. If I plug 2 into x squared, then I'm going to get 4. If I plug 4 into x squared, I'm going to get 16. If I plug, what is that, 6? 6 into x squared, I'm going to get 36. And if I plug 8 into x squared, I'm going to get 64. So those are the heights, the y values. This is a height, that's a height, that's a height, and that's a height. Those are the heights of each of my rectangles. The width of each of my rectangles is 2. So I'm going to write, let's just do this, 2. The width is 2 of each of our rectangles. So what I would have to do is I would have to go 2 times 4 to get the area of the first rectangle. Then I'd have to go 2 times 16 to get the area of the second rectangle, so on and so forth. 36, and then 64. Alright, now let's see if our answer's in here. Okay, let's see. Nothing looks like what I got. Oh, except for this guy right here. It looks like we just factor out this 2 from all of these. So we have 4 plus 16 plus 36 plus 64, which is exactly what that is. So C is our answer. Alright, number 18. Wow, this one's tricky. So this problem right here is trying to see if you understand the connection between an exponential growth function and the differential equation. Now, a differential equation that relates to exponential function says that if your rate of change is equal to, or I'm sorry, if your rate of change is, that's the equals, is proportional to the current value, then you have an exponential function. So let me use y's for an exponential function. We would have y at some time t would equal y naught, which is the very first initial amount, times e to the kt. K is your rate and t is your time. This is your current value. So this is this y right here. So if I'm looking at all these right here, this is close. This is close right here. I'm kind of annoyed by it because they didn't put a t right here, but that doesn't make it wrong. This does make it wrong. That rate is incorrect. Our rate is 3%, which is the same as 0.03. So this one can't be right. Then I look at B. This one is just like A, except they put a 3 instead of a 1.03. So that one's wrong. And then we get to weird stuff. Now it says dp over dt. Well, that's the same as y prime. That's like saying p prime equals p naught e to the 0.03t. Now this one's cool because the rate is correct. However, this is weird to say. This is not y prime. So this should not be dp over dt. It should not be p prime. So C is wrong. This one right here is exactly what this is supposed to be. Since my k is 0 or 0.03. That's our answer. It's D. It's clear as day. All right, let's look at number 19. Okay, so we're talking about a particle that's traveling on the x-axis. So really we're just traveling on a line here. So our particle right now is at 1. Now this is when t equals 0. We are right there. And so this problem is saying, okay, so when t equals pi, when we're pi seconds, is it seconds? No, it doesn't tell us what units it is. Just t equals 0, t equals pi. Okay, so when t equals pi, we'll just say seconds for the heck of it. Where are we going to be? What is our movement, or what's the total distance that we're going to be away from 1? I'm curious if we're going to go this way to some number over there, or if we're going to go this way to some number over here. Now this is not a distance formula, that is a speed formula. So if we want distance, we're going to have to take the antiderivative of the speed formula. See, the big idea in calculus says that if you have f, you take the derivative, you get f prime. Or if you have the distance formula and you take the derivative of that, you're going to get velocity, speed. So we need to go backwards back to distance. So in order to write this distance formula, we're going to write, hey, let's do it like this. Let's go d of t, the distance traveled at time t, is going to equal the integral of v dt. And v equals, let's see, 6 sine of t over 2 dt. So that means this would equal our distance. Now we're trying to find out where or how far we have traveled. This would actually find us displacement. How far we have traveled after pi seconds. So we're going to start at 0 seconds. We're going to go to pi seconds. All right, let's do this problem. First, we have a 1/2 t inside of sine. So I'm going to make that into my u. Let's say u is 1/2 t. And take the derivative of both sides. We get du over dt, because we're taking the derivative with respect to t. We get 1/2. I'm going to move this dt to the other side. Now, let's see, I don't have a 1/2 dt. So I'm going to multiply both sides by 2. So I just have a dt, and I'm going to substitute 2 du into dt. So let's rewrite this. We have, we're going from 0 to pi. We have 6 times sine of u, and then we have du, but it's 2 du, so we're going to have to change this to a 12, so it's 12 sine u du. The antiderivative of sine is cosine, actually it's negative cosine u, and then we have 0 that we're going to plug in, and pi. I'm going to go ahead and take this 12 out. Oops, I put 12 there instead of pi. Put this 12 right here. Okay, so I first plug in pi, so I have negative cosine of pi, and I'm going to subtract from that negative cosine of 0, which does equal 1, so cosine of 0 is 1, and then negative cosine of pi, so it would be negative 1. Alright, cosine of pi is negative 1. Then we have to multiply that by 12, so that's a positive 1, so this is a 2 times 12, we get 24. And oh man, I just saw my mistake. Okay, so let's back up here. My mistake was I plugged in x's instead of u's. So I should not have plugged in pi and 0. Let's see, let me erase those. Let's see what I should have plugged in. Let's change the pi into a u. So if I plug that into t right here, that would be pi over 2. And then if I plug 0 into this, that would be 0. So this would be pi over 2, and this would be 0. So I plug in pi over 2 first, so I have negative cosine pi over 2, and let's not forget we're going to multiply this by 12 when we're done. So I put my 12 out in front. Now I'm going to subtract negative cosine of 0. So that would be a positive. Cosine of 0 is 1. Cosine of pi over 2 is 0. So we have a 1 times 12. That gives me 12. Now, this is tricky because what this tells me is the displacement. So from where we started, which was at 1, we're going to add positive 12. And so we're going to add 12 this way. If it said negative 12, like if our answer was negative 12, then we would have went 12 that way. So we are currently at 13, and that's our answer. And last one, this is an exponential function. We have a formula for this one that we worked on before. So if we take the integral of an exponential function, our answer is going to be a to the x divided by natural log of a plus c. Alright, so first of all, we have a function inside of a function, so let's get rid of that x divided by 2, and let's use u-substitution. So u equals x, let's say 1/2 x instead of x divided by 2. We get du over dx, and this side we get 1/2. We're going to move that dx to the other side. Okay, and we don't have a 1/2 dx, so let's multiply both sides by 2. So we have a dx, and we're going to plug that 2 du into dx, and we're going to plug u into the 1/2 x. So let's do that. We have what is that, 3 raised to the u power du, and we're going to have a 2 as our scalar out in front. Alright, so we have 2 multiplying to the antiderivative 3 to the u power. Let's see what we get. We get 3 to the u divided by natural log of 3, and then we're going to go plus c. Multiply both of these by 2, so we get 2 times 3 to the u power. The u's looking kind of weird. Divided by natural log of 3. And then when I multiply 2 times c, we just get another c. So it doesn't matter. We don't say 2c. And then we have to plug back into u what u is. U is x divided by 2, or 1/2 x. And it looks like this is our answer. It just looks slightly different because I took this guy out of the fraction, but it's still the same. And there you have it. I hope that helps you guys. Don't forget, you want to try these problems again in 24 hours, or try other problems that are just like them to confirm that you understand this stuff.